series of examples of different kinds of forces. If someone were to push on your shoulder or pull on your arm, you could feel the force. You can also feel the force indirectly. If somebody were pulling on a rope you were holding, you could feel that force. Or if someone were pulling on a spring you were holding, you could feel that force as well. Inanimate objects can also feel forces. Here's a weight hanging from a string, and this weight feels the tension in the string pulling up on it. Also, if you have a weight hanging from a spring, the weight feels the upward force of the spring acting on it as well. Now the spring is kind of obvious because you can see the stretch of the spring. You can see from that that the spring is pulling up on the object. It's a little less obvious with the string. The string stretches a little bit and allows the string to pull up on that object as well. There's another force we need to look at. Force of the table on the book. That force of the table on the book is a support force of the table on the book. It's always perpendicular to the surface. Mathematicians use the word normal to mean perpendicular, so that physicists use the word normal to indicate the force. So the support force of the table on the book is called a normal force. Now, it may be a little not obvious to see that support force exists on the book, so we have a couple of demonstrations to help you with that. There's a platform with springs on it, and I put a heavy weight on here, and you can see the springs compress just a little bit. That suggests that the platform is exerting an upward force on the weight. There's another example we can give also. We have a meter stick suspended between two supports, and if we put a weight on that meter stick, you can definitely see the meter stick bow indicating that the meter stick is exerting an upward normal force on that weight. Another common force is a friction force. You can get a feel for a friction force if you rub your hands together. And as you rub one hand against the other, you can feel one hand drag against the other. Same thing happens with inanimate objects. If I pull this block across the table, one of the forces acting on it is the friction force of the table on the block that opposes the motion. So, if the object is moving this way, that friction force is the opposite direction. All the forces we've talked about so far have been called our contact forces. That is, the object in question is in contact with another object that is exerting the force. If you need to worry about what forces are acting on an object, isolate the object you're interested in, look at what's touching it, and those objects touching the object in question are exerting forces. You can identify those forces. Another classification of forces besides contact forces is action at a distance forces. For example, if I drop this ball, while the ball is falling, the earth, which causes the force, is not in contact with the ball, but yet it exerts a force on the ball. So it's called an action at a distance force. Another example of that is a magnetic force. Here we have several little magnets. And you know that like poles repel and opposite poles attract on magnets, so these magnets are set up so that their like poles are next to each other, so they're repelling each other. And you can see that the magnets aren't touching each other, but yet they're exerting forces, so that's another action at a distance force.